continue with with our with watching the presentation for lesson 3.1 na sinimulan natin last session. Okay? In which itutuloy natin kung saan kayo natapos last time. Okay? And then itutuloy natin kung ano yung matatapos pa natin. Okay? So as you can read in the chat box. Okay? So meron akong gagawing announcement sa with regards sa inyong quiz number 2. Okay? Kaya lang sa ngayon tinitingnan ko pa yung implications nung mga actions na gagawin natin regarding your quiz number 2. So pinaplano ko siya mabuti. Okay, so abang lang kayo. Basta within this week magkakaroon tayo ng announcement about your quiz 2. Okay? So ayun. Then otherwise you should be looking for, or you should be working on your homework 3. Kung ano na yung kaya nyong masagutan in terms of the reading materials na available, yung napanood nyo ng presentation, and yung naaral nyo na. Okay? So sige, let's continue on with watching yung ating presentation. Okay, saglit lang . Again, if again, if may questions kayo, ganun nyo lang ipasa nyo lang sa chat box natin. Okay, thank you. Kumbaga, yeah, we should recognize the form of the formula or the look of the formula. But when we are to use this formula to actually determine y of n, we will be remembering more of the steps involved. Meron bang audio yung video?
Meron po, sir.
Meron. Sige, thank you. In the formula rather than the formula itself. So here are these are some of the terms that we will have to use. In this formula, we say that xn is convolved with hn. Or we also say that yn, ito rin yung term na here we can use this phrase para to describe equation 3. Xn is convolved with hn to produce y of n. Yan, isang phrase na applicable yan dun sa equation 3. Okay, also we can say that y of n is the convolution sum of xn and hn. So these two phrases are correct ways of reading equation 3. Okay? So ayun. And yung mga derivatives ng mga phrases na yan. Okay. So ano yung operations? What are the operations involved in the convolution sum or in the algorithm of obtaining the convolution sum of two sequences? Okay? So the first one is folding. So here, based dito, okay, ang output index kasi natin is n. Okay? So, our output has an index of n. Okay? So therefore, it means that if you are to substitute anything inside this summation formula, okay? You would have to replace n with k. Okay, papalitan mo lahat ng substitute natin sa loob ng formula na to, okay, has to be replaced with k. Lahat ng n has to be replaced with k. So, substitution into 3, okay, requires replacement of the variable n with k. So lahat ng n, okay, ibig sabihin pag nagsubstitute kayo ng x of n dito, lahat ng n nung x of n gagawin yung k. So that it becomes x of k. Okay? So same thing with h of n. H of n. If you substitute h of n here, okay, you have to replace all the n's. Okay? All the n's of h, okay, into k's. Okay? Now what would happen is that so yung h of n niyo, yun yung magiging h of k. Now the first step, what you would do after that is you fold now your h of k. So that's the first step in the algorithm. So you fold now h of k, okay, about k equals 0, okay, to obtain the time reverse or the time folded version of h of k. Okay, so that's the first. Okay, now next step in the algorithm is shifting. Okay, now yung folded h of k niyo, which is now h of negative k, has to be shifted by n of 0. Okay, I'll explain the significance of n of 0 later on. Okay, pero may importanteng role na i-play yung value ng n of 0 sa algorithm natin. Okay, so then this is the n of 0 here is the amount of shift to be done, okay, for h of negative k. Okay, so just remember that if tandaan natin to, since we will be shifting h of k by n0. Okay, so this becomes h of n0 minus k. Okay, we remember lang that if n0 is negative, okay, you're actually shifting your signal to the left. Okay, so kapag yung since this is time reverse this is a time reverse signal already. Okay, time reverse signal already to. So ibig sabihin kapag shift nyo si time reverse signal with a negative shift, okay, with a negative amount of shift, okay, the signal values tend to go to the left. So basically kapag negative yung n of 0 nyo, the shifting is more of an advanced operation. Okay? So the resulting h of no minus k is an advanced version of h of negative k. Okay? While kapag naman positive yung no na yun natin sinubstitute natin or shift natin, if we shift h of negative k with a positive amount of shift, okay, the sample values tend to go to the right, which means the sample values tend to be delayed. Okay? So, ayun. Tandaan natin na kapag ang amount ng no natin is positive, okay, we shift the signal to the right, while if it is negative, we shift it to the left. Okay? So, ayun, nandito tayo sa h of no minus k. Now, bakit siya h no? Kasi yung yung n0 kasi na yan is actually a particular value. Okay? Which will actually determine later on na yan yung kino-compute nating sample value sa isang particular time index. So at say for example, if your NO is actually say for example -6, you're actually computing for the value of y when n is equal to -6. Ito yung kino-compute nating sample value. Okay? So, yun yung yun yung parang pinaka role na ipi-play nung n0 dito. Okay? So, ayun. Now, so after shifting your h h of negative k, okay, with n0, okay, what you now do, okay, is to form the product sequence xk and the shifted time reversed version of your h. I-multiply natin si xk, okay, i-multiply si xk at saka yung shifted and time reversed then shifted h ninyo, okay, para mabuo natin tong product sequence na to. Okay? So, we'll call that product sequence as V of K. So, ayun. Remember that this product sequence now is a function of K. Kasi again, pag nasa loob tayo ng convolution algorithm, yung time index natin nagiging K instead of N. Although later on sa operation natin, hindi natin papansin hindi natin madidistinguish yung difference na yun kung nasang domain tayo. Okay? So, ayun. Then finally, once na mabuo niyo yung product sequence na xk and hno minus k, you'll add up. Okay, you'll add up the values of the product sequence. So lahat ng values ng product sequence to, i-add nyo. Okay? Now the sum, okay? The sum would amount to the value of the output at time n equals no. So ito yung sinasabi ko kanina. Again, kung ano yung value ng NO na ginamit nyo to shift your H, okay, that would actually determine kung anong time index or kung anong kung anong time index ng output ang kino-compute natin. What would be the time index of the output that we are computing? So say for example nga, if your NO, the shift that you have used is -6, then you're computing for a value of -6. Okay? So that's the algorithm involved in the implementation of your convolution sum. So again, if you think about this on the algorithm standpoint, it might be sometimes confusing or something like Okay, and you might be perplexed na i-implement ba namin sa MATLAB yan? Okay. Well, the good thing about this is that this is already implemented in the MATLAB. So we will just do some konting modification. Gagawa tayo ng konting modification dun sa built-in convolution function sa MATLAB. Then we will be able to use this in the manner that we are trying to discuss. Okay, yung consistent siya sa discussion natin, yun. So there. So again, the four steps, okay, in the implementation of the algorithm of your convolution sum is folding, shifting, multiplication, and then summation. Ngayon, ulit-ulitin niyo yan actually. Especially itong 2 to 4. Okay? So, ang mangyari kasi diyan is that you would have to have the shift. Okay? You would have to have the shift from negative infinity, okay, to positive infinity. Kailangan yung shift nyo mag-amount from negative infinity up to positive infinity. Okay? So, that would be kasi that means that you are also computing the value of yung y of negative infinity, okay, hanggang y of positive infinity. And this applies to infinite length signals, okay? Actually, this applies to all, okay? Pero actually yung what we will do here is we will implement, okay, ito. So that dito. What we will do in this lesson is to implement the convolution sum, okay, on two finite duration sequences. So meaning meron kang xn that is finite duration. Tapos may hn ka that is finite duration. We will find out how to implement the convolution sum sa ganyan. Okay? Sa ganyang setting. Okay? So yan. By the way, this is one acceptable notation for your convolution sum. So instead of actually writing the formula tree every time that you are trying to say na ito yung convolution sum, this is actually a parang a more compact notation. Compact notation for the convolution sum. Okay? So ayan, ito yun actually, nabanggit siya dito. So, yeah. So we will implement the convolution sum on two finite duration sequences. So titingnan natin kung ano yung magiging epekto niya or paano siya i-carry out. Okay? And actually, we will use this discussion, okay? Especially yung example 2, okay? In order to demonstrate yung four steps ng algorithm. Okay? So, yeah. Now, second, we will also implement the convolution sum on two infinite duration sequences. So given naman now that your x of n is now infinite duration and your h of n is infinite duration, how do we now carry out, okay? Or how do we now implement yung equation 3 para sa mga infinite duration sequences natin? Okay? So, ayun. Yan yung approach natin para mas maintindihan natin yung ating convolution sum algorithm. Okay? So, in example 2, okay, let's discuss this example 2. We will perform the algorithm for the convolution sum. Parang mali ito. Perform the algorithm or implement the algorithm for obtaining the convolution sum for two finite duration sequences. Again, pag sinabi yung finite duration sequences, given na meron kang x of n as a sequence, okay, meron yan length na, so yung length ng x natin, okay, is equal to say n1 or nx, layer na nx. Okay, while your second sequence, h of n, okay, would have a length of so the length of h is n of h. So both of them are finite lengths or finite numbers. Okay? So those are finite duration sequences. Okay. So by the way, pansinin niyo rin dito that while h of n, emphasize ko lang ulit, h of n or the impulse response characterizes and describes hn. I mean the system. Okay? Describes the system. Fundamentally, it is still a sequence. So tatandaan niyo na yung hn natin is still a sequence. So I'm treating when we're talking about the convolution sum, okay, we're actually treating hn to be a sequence or a signal. So tinitreat natin ngayon si hn as a sequence or a signal, which means that if it is a sequence or a signal, then we can apply yung basic operations or not just the basic but all the operations that we have studied on signals. Okay? Especially if you take a look at lesson 2.3. Tama ba? Or 2.2. Simple manipulations on ano. So, may apply natin yung mga napag-aralan natin doon. Okay? So, and this is actually the beauty of the impulse response. Okay? So, not only it is the impulse response not only deals with systems, okay? It actually is a signal. Okay? It actually can be considered, or fundamentally, it actually can be considered as a sequence or as a signal. So, yun yung dito, wonder nung to. Okay, so dito, let's suppose that we are given h of n as the sequence. So, we take note that the length of h here is ilang terms to? 1, 2, 3, 4, 5. So, ang length ng nh natin is 5. Okay? While here, ang xn natin, okay, has this many terms. 1, 2, 3, 4, 5, 6. So, yung length of x natin for nx is 6. Okay? So, if you want to compute the output sequence, okay, yn, of the system described by this, basta ganito yung problem. Pag nagkaroon kayo ng problem, nagkaroon tayo ng mga problems dito, ito yung problem statement. Visually na lang given a system, whose that is being described by the impulse response hn, okay, what would be the output sequence yn, okay, given a certain xn. So, ito yung given ninyo, given ito, at saka ito. Ang tinatanong, ano yung yn? Okay, so kapag ganun yung konteksto ng tanong, then ang solution natin is the use of convolution sum. Okay, so ito yung required. Okay, so yun. So here, we are trying to find yn, given ito yung hn natin, tsaka yung xn natin. Okay, so ganito, no? We will apply. Okay, we will apply the four-step algorithm. Okay, again, that's folding, shifting, multiplication, and summation. Okay, so medyo maliit lang tong palaki natin siya. Kaya hindi ako masyadong worried na maliit yung natin, yung table natin, because alam ko may zoom naman. Okay, so now we start with substitution. Okay, so we start with substitution of of the given x and h. And now take note na yung index natin, the index now is in terms of k, not n. Okay? So yung ito yung sabi ko sa inyo na once na gumawa tayo ng substitution dun sa equation 3, okay, your index variable, okay, changes from k to n. Okay, by the way, yung mas malaking version nito dun sa files na pinrovide ko with you. So take note na ito yung sequence xk niyo tsaka yung hk niyo na sequence. Okay? So I highlighted yung mga blue. Okay, yung mga blue na empty cells. These are zero values or zero sample values for x and k. Okay? So let me just call xn or xk as x, tapos yung hk or hn as h muna ngayon para masyado tayong para for brevity ba. Okay, so ayun na nga, in-input na nga natin siya so this would be your x, and this would be your, di kita, black siguro, blue, ito tsaka to. Okay, so this would be your x and h. Now the first step is to fold. Okay, so let's fold hn. So kung ito yung hn niyo, pag finold natin yan, itong value na to, since yan ay nasa k equals 2, mapupunta yan sa k equals -2. So magta-time reverse siya. Okay, so again, review natin yung yung time reverse operation. So yung value dito sa k equals 2, mapupunta sa k equals -2. So kung -1 to, ayun, mapupunta siya doon. So ito, yung value dito, mapupunta sa k equals -1. Yung value sa k equals 0 is still the same, sa k equals 0 pa rin. This one, yung value sa k equals -1, mapupunta sa k positive 1. Okay? And then yung sa k equals -2, mapupunta sa k equals positive 2. Okay? So that's time reversal. Okay, so that's folding. Next, let's shifting. That's the next operation, shifting. Okay, so we start with with the folded H. Okay, so yung folded H natin, ito. Kinopy natin dito. So yung folded H natin, ito siya. Okay. I-shift natin yung i-shift natin ngayon si folded H, okay, by a certain amount NO or N0. Okay. So again, yung shift na yan, sinasabi natin, yung amount of shift na yan, okay, sorry. Yung amount ng shift na yan should be from negative infinity up to positive infinity. Okay, that should be the amount of shift. Okay? Medyo careful na ngayon. That should be the amount of shift na gagawin natin. Okay? But since we're dealing with finite duration signal. Okay? Since we're dealing with finite duration signal. At saka this is actually impractical naman in our case. We'll simply just use some practical values for n0. Okay? Which in this case, let's have it to be as -6 muna. Okay, so we'll shift it with we'll shift folded H. Okay, we'll shift the folded H with -6. Okay, by -6 pala, by -6. So ibig sabihin nun, kung i-shift natin siya by -6, negative yung shift means it will move to the left. The signal values would the signal values of H, okay, would move to the left by 6 time indices. Okay. So from -2, okay, mag-shift yan ng 6 na times. So 1, 2, 3, 4, 5, 6. Doon siya mapupunta. Itong -1 na sample value to, mapupunta siya sa time index na -8. So ito yun. And everything else will follow. Okay? So ngayon, itong signal yun na ngayon to, this signal now, is referred to now as H of -6 minus K. So we will refer now to the shifted signal as H of -6 minus K. Okay? And still makikita nyo yung X of K ninyo, nandito siya. The original X of K pa rin. Okay? So that's the second part of your algorithm. Okay? The third part is multiplication. Now what we will do is yung shifted yung shifted H natin, yung shifted folded H natin, okay, which is this one, okay, at saka yung X of K natin, which is this one, i-multiply natin yung dalawang sequences na yan. So we will multiply H of -6 minus K with X of K, so that we will produce the product sequence V. Okay? We'll call it V -6. Okay, I'll call it as para ma-indicate natin kasi yung shift. Okay, so V -6 of K. So we'll call the product sequence as V -6 of K. Yan. So yung product sequence na to is V -6 of K. So i-multiply natin siya ngayon, no? So this sequence at saka tong sequence na to, i-multiply natin. But as you can see, okay, ito yun. Dito natin gagawin yung multiplication. As you can see, pag minultiply ko itong dalawang to, the non-zero values of my sequence here, okay, coincides with the zero values of my signal xk. Okay? And in the same manner, yung non-zero values ng x ko, okay, coincides with the non-zero values, coincides with the zero values of of H ko. Okay? Eh kapag binuo ko tong product sequence na to, i-multiply ko siya per signal value. Okay? So i-multiply ko to, for example, then ito, then ito, then ito, ito, and so on. So ano mangyayari kapag binultiply ko siya, pag binultiply ko siya at binuo ko yung product sequence na V? The product sequence would all have 0 as the sample values. So all values of V negative 6 is 0. So ganun yung mangyayari dito. Since yung non-zero nung HK, o yung non-zero values ng HK, coincides with the zero values of x, while the non-zero values of x coincides with the zero values of h, so that the product sequence will become 0. So yun yung mangyayari sa multiplication natin. Okay? Then the fourth one. Okay, so yun nga, observe the table that the two sequences, okay, and h of negative 6 minus k and xk, ito, do not have any overlapping non-zero terms. Yan yung tatandaan yung term na gagamit natin mamaya. Overlapping non-zero terms. Okay? So therefore, kapag wala silang overlapping non-zero terms, that means the product sequence, okay, is then 0 for all values of k. So lahat ng values of k ngayon, okay, would be, lahat ng values of the product sequence would then be 0. And that thing, okay, the possibility of your all values of product sequences of the product sequence V and O of K becoming all of them 0 for all Ks, okay, becoming all of them 0 for all Ks is possible if both X and H have finite lengths. Ibig sabihin, kapag ang X ninyo at saka ang H ninyo are both finite duration signal, yung possibility that this product sequence will become 0 for all case is likely to happen. Okay, mangyayari at mangyayari yan. So, kailan siya mangyayari? Ito yun. If in the instance na yung shift, if the shift, okay, if the shift NO, okay, produces non-overlapping, saan tama yung spelling ko? Overlapping. Non-overlapping, non-zero terms for the shifted H, okay, and XK, then ito yung mangyayari. Pag shift nyo si HN, si H, okay, pag finold at shift nyo siya, okay, and it turns out that that shift, okay, produces non-overlapping non-zero terms. Ibig sabihin, yung mga non-zero terms nung dalawa yung sequence are not overlapping. Okay, then ito yung mangyayari. The product sequence will become 0. So ano bang significance kapag yung product sequence yung 0? Okay. It means kasi pagdating sa summation, kasi the fourth step is to sum up the values of the product sequence. Okay, isa-sum up kasi natin yung values ng product sequence niyo. So ano mangyayari doon? Pagka nangyari na ang product sequence niyo ay 0, if this turns out to be if it turns out that if all V and O case equals 0 for all case, okay, then yung magiging sum nila, okay, the sum, which actually magiging y of n0. That's actually the value of your that's actually one of your sample values that you're looking for. Isa to sa mga sample values na hinahanap nyo. Okay, so that would be the sum eh. Pagka inad nyo kasi yung sample values na to, yung product sequence na to, okay, yung sum niyan, isa sa mga sample values na hinahanap niyo. So therefore, yung magiging sum na yan, magiging equal din sa 0. So say for example, katulad sa case na to, okay, since yung product sequence nyo, okay, since the product sequence here are all 0, okay, since the product sequence here are all 0, pag inad nyo lahat yan, okay, magsasama pa yan sa 0. Eh yung sum na yan is actually equal to y of negative 6. Okay? So again, y of n0, okay, equals the sum of x of k, h of n0 minus k, okay, for k equals negative infinity up to positive infinity. Ito yung product, itong product na to, yan yung v of ano nyo, v of n0 ninyo. So ngayon, pag inad ko yan, at walang lumabas na sum yan, therefore, yung signal value at this particular shift will also become 0. Okay? So here, in this case, since ang NO natin is negative 6, so we're looking for y of negative 6 actually, which is the sum of v negative 6, okay, of k, for k equals negative infinity up to positive infinity. Which again, ito, lumalabas, 0 siya. So therefore, yung y of negative 6 natin, 0. Okay? So, ayan. So we find that y of negative 6 is 0, as indicated in this table. Ngayon, uulitin natin yung actually, folding, shifting, multiplication, summation. Uulitin natin tong apat na proseso na to. Although, syempre, hindi natin ulitin yung folding kasi na-fold naman natin siya. Okay. So, ang gagawin natin is yung shift natin, i-adjust na lang natin. Okay. Galing sa negative 6, then we will have to adjust it to negative 5. Because, again, it would not make sense kung i-adjust pa natin siya sa negative 7, for example. Kasi nga, kung wala nga tayong nakitang overlapping non-zero values dito at saka dito, pag ito, nilayo nyo pa, okay, by having the shift to be negative 7, okay, kasi pag ginawa nyo negative 7 yan, gagalaw pa ng pakaliwa lalo yan. Kasi this shift is for negative 6 eh. So kapag ka mas negative pa yung i-shift nyo sa kanila, mas kaliwa pa yung galaw niya. Okay, so it would make sense na i-shift natin siya with less negative shift. So n0 equals negative 5, i-shift natin siya para mag-shift siya sa kanan. Okay, so ulitin natin yun. Okay, so in this case, para mas madali din yung discussion, okay, dahil nakita niyo naman na yung sense nung algorithm, okay, at ano yung mangyayari or mga possibilities of what will happen for a finite duration signal. Once we do the shift, maghahanap din tayo ng shift that produces overlapping non-zero values for h and k. So maghahanap tayo ng shift na meron tayong mamumultiply so that the product sequence is not entirely 0. Okay, so ito yun. In general, we seek the amount of shift NO that will cause the sequences h and k to have overlapping non-zero terms. Yan. So kapag if h and k have overlapping non-zero terms, this would mean that your VNO, the product sequence, the product sequence may have non-zero values, and therefore that would lead to your sample value, or sample sequence to have non-zero to be or maybe So your y of n 0, sorry, ayan, may be non-zero. Yan. Okay? So yun ang hahanapin natin. We would try to seek the amount of shift NO that will cause the sequences H and K to have overlapping non-zero terms. Kasi at that particular point, that means that your product sequence would have or may have non-zero values. And again, emphasize ko lang na may kasi baka mamaya lagi niyong sabihin na okay. May kasi baka mamaya naman kasi even if they have overlapping non-zero terms, baka naman yung mga products talaga nila magko-cause na maging zero siya. O kaya yeah. Okay. O kaya meron ngang mga terms yung product sequence niyo, pero pag in-add nyo, magli-lead pa rin sa zero to. So that is why yung y of n0 nyo may also be non-zero. Okay, so emphasize lang natin yun kasi baka mamaya yung mga expectations natin Okay, so again, even if you have kaya may at saka may ang ginagamit nating mga terms dito. Okay. But still, ang hinahanap natin lagi is the amount of shift that that would have this H and K to have overlapping non-zero terms so that we can multiply non-zero signal values and therefore produce terms for your product sequence to be non-zero at baka sakaling meron tayong may-add so that magiging non-zero din yung output natin. Okay, and it would also be you could also imagine that the amount of shift, okay, the amount of shift that you would be doing this is actually also finite. Ibig sabihin yung number of shifts na gagawin niyo to is also finite. Kasi it's simply because kung titingnan niyo tong kung titingnan niyo tong table at kung imagine niyo kung paano siya magpo-progress by actually by actually doing the shifts for n0 equals -6, n0 equals -5, n0 equals -4, and so on. May imagine niyo na there will only be a finite amount of shift, okay, that will result to H and X having overlapping non-zero terms. Okay? So, since yung length ng X ninyo, yung length ng H at saka ng X ninyo are both finite, okay, you can just imagine na yung number of shifts nito would also result in a finite amount of shift. Okay. In fact, kung titingnan niyo mabuti to, okay, kung obserbahan niyo to, since dun sa amount of shift na -6, okay, wala na tayong nakitang overlapping, there's no overlapping non-zero terms. Okay. Di what more kung i-shift ko siya for -7, -8, -9, -10, and so on. Okay. So, in that case, we can conclude actually that at least at this interval, for n between -infinity hanggang up to -6, there will be no overlapping non-zero terms. Yan. There will be no overlapping non-zero terms. Okay? So therefore, kung ganyan yung case, we can conclude that from negative infinity up to -6, then we can consider that your y of n is 0. Your output sequence is 0 for this interval. Okay? So there. Now, if you continue on, actually even for n equals -5, wala pa rin kayong makikitang non-overlapping terms. Wala pa rin kayong makikitang overlapping terms, sorry. There is still no overlapping terms. Okay? So, there is still no overlapping non-zero terms. Ayan. So, So kung wala pa rin siyang overlapping non-zero terms, that would mean that the sample value or the output sequence would still have a value of 0. Okay? Now, for n equals 4, ito yung scenario. Okay, for n equals 4, ayun. Makakakita tayo ng first makakakita tayo ng first overlapping non-zero terms natin. Okay? Wherein yung sample na 3 ni H at saka yung sample na 3 ni X, magtatagpo sila. So that if you form the product sequence, if you multiply these two sequences, okay, you would have the following values. 0 siya at this time indices. Now at k equals -2, okay, at k equals -2, meron siyang value na 9. Okay? And then for k greater than -2 or for k higher than -2, 0 ulit siya. Okay? But nevertheless, hindi natin concern yung mga zeros na yun. Okay? But what we will do after that, okay, is i-add natin yung mga values na yun, yung 0 plus 0 plus 0 and so on. Okay? The important thing is that makakabuo tayo ng magkakaroon tayo ng non-zero sum. Okay, which is now 9. Okay? Now since ang amount of shift na in-employ nyo dito at this step is -4. Okay? This 9 here actually turns out to be the value of y of -4. Okay? So recall lang natin ang value nung y of n niyo. Okay? Ang mga signal values ng y of n niyo na na-obtain natin so far is 0 siya. Okay? This is for n between negative infinity up to -5. Okay, yan yung nakuha natin. 0. Lahat yun. 0 yan. Okay? Now, when when n becomes -4, okay, makakakuha tayo ngayon ng 9 as a value. Okay? So, ayun. So, next. We proceed with n equals -3 as the shift. So, in that case, dalawa na yung overlapping non-zero terms sila. Okay? So, in this case, your product sequence would then be 0 dito. Okay? Tapos meron siyang positive 3 when k equals -2. When k equals -1, that is -3. Tapos 0 ulit siya. Okay? Which again, i-add natin lahat ng values ng product sequence niyo. And it turns out na magiging 0 siya. Okay? Ito yung sinasabi ko kanina. Hindi ibig sabihin na meron kayong product sequence na non-zero. Magkakaroon na kayo ng non-zero na y. Okay? That is because baka mag-add up kasi sa 0 yung mga terms ng product sequence niyo. Okay? So, but in any case, itong value kasi ito na 0 is considered to be still within the range of or within the interval of y. Kasi meron na siyang katabing non-zero term. Okay, may nauna na sa kanyang non-zero term. Okay, at unless ang pagkatapos itong 0 na to, okay, puro 0 na ulit. Okay, then this is considered to be parang hindi na part ng signal niyo. Okay? Unless kung ang mga kasunod niyan ay puro 0 na. So, pero kapag ang kasunod nito is non-zero ulit, then this is part of the this is part of the signal or the part of the output sequence. Okay? So, now, so far, again, ano nakuha natin? Okay? Is, again, 0 siya. Okay? For negative infinity, up to -5. Okay? Tapos nakakuha tayo ng value na 9 for n equals -4. Tapos nakakuha tayo ng value na 0 for n equals -3. Okay. Now, I want you to continue on yung implementation ng algorithm niya. Okay? For n equals -2. Okay? So, for n equals -1, 0, 1, and 2. Ayan, sinabay-sabay ko na. So, ito yung para sa -1, ito yung para sa 0, ito yung para sa 1, ito yung para sa 2. Okay? So, Ito yung mga product sequences natin. Yan. And then, pag in-add nyo yan, okay, you would have this as the values for your output response. Okay? So, ito yung mga values na yun. 8, 9, 12, and 8. And then, for the rest of for n equals 3, 4, and 5, kung titingnan natin yung n equals 3 dito, ito. This is for n equals 3, shift na equal to 3. This is shift na equal to 2. 4, I mean. Again, mapapansin nyo ngayon positive yung at this point, positive na yung shift. Okay, so if the shift is positive, ito yung original na h ninyo. Okay, pag positive na yung shift, dapat nasa kanan na nung original na h of negative k, yung shifted version. So, ito na yun. Say for example, for h equals negative 3, ito na siya. So, delayed na siya with respect dito. Okay, this is h of 3 minus k. So again, pag positive to, you tend to move the signal values to the right of the original signal values. So delayed na siya. Okay? So now, for n equals 3, 4, and 5, we notice na pagdating sa 5, isa na lang yung okay, isa na lang yung terms that are non-zero terms that are overlapping for h and k. Okay? So that pagdating ng 6, wala na. Okay, wala nang overlapping terms. So ito yung sinasabi ko na finite lang yung number of times na magkakaroon kayo ng overlapping non-zero terms. Okay, so there will be finite number of shifts that produces overlapping non-zero terms. Okay? And this applies for finite duration x and finite duration h. Okay? Kasi you can imagine na na after ng y of 6, say for example for the shifts 7, 8, 9, 10, 11 and so on. Wala na talaga kayong makikitang overlapping non-zero terms. So that you can consider that from 6, okay, up until positive infinity, again, yung magiging value ng signal niyo is 0. Kasi nga wala nang overlapping non-zero terms eh. So 0 yan because no overlapping non-zero terms starting from 6. Okay? So we say na from negative infinity to mali pa to. From negative infinity to negative 5, okay? And from 6 to positive infinity, okay? Yung y of n niyo is 0. So saan lang merong non-zero yung y of n niyo? Yung y of n niyo ngayon is defined from negative 4, n equals negative 4 hanggang positive 5. So from negative 4 to positive 5, ito yung magiging sequence niyo. So ito. From n between negative 4 to positive 5, ito yung magiging sequence yn niyo. Okay? So ito yung the signal value for n equals negative 4, negative 3, negative 2, negative 1, for n equals 0. Kaya nandun yung marker natin. 1, 2, 3, 4, and 5. Okay? So, yan yung magiging convolution. Ito ngayon, this one, ito yung mga tawag natin dyan. This is the response of the system Hn to Xn. Okay? Or pwede rin ito yung output sequence produced or generated by feeding Hn with Xn. Or feeding your system. Kasi yung Hn tries to describe the system or tries to represent the system. So pag nilagay ko yung Hn dito, it means feeding the system. Okay? or response of the system HN. Okay? So, ayun. And XN here is the input signal. Okay? So, or simply, we can refer to the sequence YN as the convolution sum. Okay? So, the sequence YN here is the convolution sum of the sequences XN and HN. Okay? So, in particular, if Xn is an input, okay, to an LTI system whose impulse response is Hn, then Yn would be the system's response. Okay? So again, sinasabi natin that we recall, no? We recall that ano yung NX tsaka NH? Layo na kasi. Ayun. So ang NH natin is 5, ang NX natin ay 6. Okay, balikan natin siya dito. Okay, so we recall that our NH parang nakalimutan ko yung kinuha natin kanina. Ayun, ito na pala. Ang NH natin is 5. This is the length of H. Okay, while this is the length of X. Okay. Length means the number of terms, okay, or the number of sample values. Length of X. Okay. So, since both of our signals, both of the input signals that we have considered here are of finite duration. Okay? So, dahil ang kinonsider nating input or ang kinonsider nating sequences in this example are both finite duration. Okay? It turns out that the convolution sum of two finite duration signal is also a finite duration signal. Okay? So kung finite duration yung sequence xn niyo at saka hn niyo. Okay? Which in this case nga 6 yung length ng x at saka 5 yung length ng h. Okay? It turns out na yung yn niyo will also have a finite length. Okay? And there is a way for us to predict. Okay? There is a way for us to predict yung length of y. Given na alam natin, okay, yung length ng x at saka yung length ng h. So that formula that predicts that is given in this one. So the length of y is the sum of the lengths of x at saka h then minus 1. So in this case, the length of x is 6 then plus 5, okay? Then minus 1 natin as part ng formula. So this is 10. So mabibilang natin na yung y niyo has 10 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So yun. So those would be that is how we implement the convolution sum, okay? Algorithm. Okay. So again, kung titingnan niyo mabuti yung steps, okay? Consistent naman siya with equation 3. Okay? The algorithm is actually very consistent with equation 3. Okay, which is why kailangan natin tandaan talaga yung apat na steps. Okay, in the implementation of the convolution sum. Okay, so folding, shifting, multiplication, and ano siya? Summation. Okay, sorry. So, ayan. So, now, ito lang, additional para mga additional facts lang about the convolution sum. Okay? Especially in the context ng discrete time signals. Okay. Una, gamitin lang natin yung mga input signal natin. Okay, so ano yung input signal natin? So these are parang fun facts about ewan ko kung fun sa inyo to, pero this might although I don't recommend din you computing the convolution sum using this way. Okay? since naka-ano naman kayo, naka-online naman tayo, eh, wala namang masama kung ano, wala namang masama kung, i-compute niyo yung, convolution sum using MATLAB or using Excel. I really don't recommend computing the convolution sum this way, okay? Tinuturo ko lang 'to nung time ng face to face because pagka quiz siyempre kailangan mo ng mabilisang way to actually compute the convolution sum. Okay, ito, unang-una, um, i-assume natin na itong mga 'to, okay, are actually these vectors. Okay, let's assume that these are vectors. These vectors are coefficients. Okay, coefficients of a polynomial o polynomials kasi dalawa sila eh. So dalawang polynomial ma-define natin. So assume that these vectors are coefficients of polynomials. So what I mean is this one. Say the polynomial p, okay, using h as its coefficient in terms of x or as a function of x would be ito yung pinakadulong ito yung constant ng polynomial. Ito yung dulo na to, yun yung constant ng hindi, since meron ka palang meron ka palang n equals 0. Okay, n equals 0. So ganito pala. Yung n equals 0, yun yung exponent niya. Okay, nung x. Okay. Say for example ito, this would be this would be given as 0, 1, 2. Okay. So this would be negative x square, okay, plus x, okay, plus 2 plus x raised to negative 1, okay, plus 3x raised to negative 2. Okay, that's for the polynomial in terms of the h as coefficients. While for x, okay, p of x as a function of x. Okay, so this would be, kung n equals 0 to, it's 1, 2, 3. So this is x cubed plus 3x squared, okay, plus 2x plus 1 minus x raised to negative 1 plus 3x raised to negative 2. Okay? So again, yung mga coefficients na to, okay, the coefficients of your polynomials are based on these vectors. Tapos yung yung n or the time index are actually exponents of the variable multiplied to that coefficient. So actually, itong representation na to, later on na makikita nyo yung inaaral din actually sa sa ibang sa ibang fields of study, like for example sa encryption, sa data communications. Okay. Actually represents both both the signal values and the time index. So dito kasi pinapakita lang natin yung signal values lang. Tapos yung time index pinapakita natin in another way. Dito ginagawa natin tong parang formula na kagad. Okay? So both signal values and the time indices or time index are indicated. So again, yung representation na yan nung vector as a polynomial is something na ginagamit talaga. Are indicated. Now, ito yung point ko. I want to produce the product the product of the polynomials p times h, p of h, ph times px. So, i-multiply natin siya. Okay. So, para ma-multiply natin siya, syempre yun, multiply siya. Ang gagawin natin, first is to actually write the polynomials. So, this is x cubed plus 3x squared plus 2x plus 1 minus x raised to negative 1 plus 3x raised to negative 2. Tapos, ito, yung isa naman, yung kung paano kayo mag-multiply ng polynomials nung high school kayo. 'Di ba? Ina-arrange siya on a vertical manner. Pinag-group grupo nyo on a column yung mga magkakapareho yung exponent na variable. Say, this one, this becomes negative x square plus x plus 2 plus x raised to negative 1 plus 3x raised to negative 2. So, i-multiply natin yan. Okay? I-multiply natin siya. Okay. Tingnan nyo magiging tingnan nyo magiging sagot. Okay. First, so ito, multiply dito, no? So, you would have 9x raised to negative 4 plus negative 3x raised to negative 3. Okay. Plus 3x raised to negative 2. Okay. Plus 2 x raised to negative 1 plus 9x raised to 0. So, 9 na lang yan. Okay. Then, plus 3x plus tx. Okay. So, that's for this one. Okay. Next. Ito. This is positive 3 x raised to negative 3. So, pwede kong i-add to kasi pareho siya ng exponent. Okay. Minus x raised to negative 2. Okay. Actually, yun yung value kung bakit nyo pinagsasama-sama sa isang column yung para kapag multiply nyo siya, magkakasama rin yung products nila sa isang, magkakasama din yung mga magkakaparehong exponent sa isang column. So, you'll have plus x raised to negative 1, then plus 2, then plus 3x, okay, and then x squared. Okay, so let me just work on this offline para hindi naman tumagal tong recording natin. Okay, so tapos ko na siyang i-multiply. Okay, meron lang akong ginawang correction dito. Ito, parang 1, 2, 3, 4. So 1, 2, 3, 4. Ito, 6 pala product niya. Okay, 6 x raised to negative 1. So, yun, kinurek lang natin. Okay. Ngayon, niligay ko dito yung yung part ng table which shows the the product sequence for n equals negative 1, 0, 1, and 2. Okay, pero pansinin niyo to sa lahat ng ng ituturo kong Okay, ito yung gusto kong i-point. If you actually try to notice yung values nito. Okay? Yan, yung values niyan, for example. Again, take note that yung exponent ng nung x raised to negative 1 here, itong exponent ng negative 1, actually depicts the time index n equals negative 1. Okay? Tandaan natin yan. Kasi yun yung ginawa natin yan dito convention dito Okay? So, yung x raised to negative 1, yung exponent nun, okay, actually depicts the time index negative 1. Now, what I'm trying to point out here is if you actually look at the product sequence when n equals negative 1, okay, the terms of the sequence or the terms of the product sequence would be, na dan 0 would be 3, negative 2, 1, and 6. Three, negative 2, 1, and 6. Diba? So, may konting magic dito, no? Okay? So, anong ibig sabihin nun? Sa standpoint ng multiplication ng polynomials, syempre, pagkatapos kong i-multiply lahat ng polynomials yan, i-add ko yan. So, that would become 6 plus 1, 7 plus minus 2, so that's 5 plus 3. That would be 8x raised to negative 1. Okay? So, yung magiging sum nun, nung is 8x raised to negative 1. Kung titingnan yung operation na ginawa natin dito, i-add natin to That's 3 plus negative 2 plus 1 plus 6. That should sum up to positive 8. And that's the value for your output sequence na y of negative 1. Again, yung 1 dito pertains to the time index n equals negative 1. So, ano yung point ko? Okay? Ano yung point ko? Discrete time convolution sum is actually analogous to it's actually analogous to polynomial multiplication. Okay? Kaya actually, it's actually analogous to polynomial multiplication. Okay, so the algorithm that fold, shift, multiply, and sum is actually an algorithm. Okay, that is used also in multiplying polynomials. Okay, and this is kung pag-isipan nyo pa mabuti at naturuan kayo ng iba pang technique sa pag-multiply ng polynomials nung kayo ay nasa high school. Say for example, if you have to multiply x plus 1, multiply 2x plus 1. Halimbawa lang para medyo simple lang yung problem. Ang ginagawa nyo ginagawa nyo yung table. Like, nilalagay ko nyo yung coefficients nung isang polynomial yun, horizontally, yung isa naman vertically. So say for example, for x plus 1, you'll have it as 1 and 1 here. Tapos ito naman, vertically. So 1 and 1 here. Tapos gumagawa kayo ng multiplication table dito, such as magiging 1 times 1 is 1, 1 times 1 here is 1, 1 times 1 here is 1, then 1 times 1 here is 1. Tapos ginagawa nyo to. Yung diagonal addition. So, yung first diagonal sum nyo is 1. Tapos yung second diagonal sum nyo, ito, okay, is 1 plus 1. So, that becomes 2. Okay. Then yung last diagonal sum nyo, okay, is 1. Okay. You'll see na if you actually put in yung x at saka yung constant dito, and yung x at saka yung constant dito, you'll observe na yung magiging product dito, okay, is x squared. Tapos ang coefficient niya ito. So that would mean that yung first term ng product nito is x squared. Okay? While yung product na x at saka k dito, actually x at saka constant actually pertains to the product x. Okay? Tapos yung coefficient niya dito, yung product ng coefficient na 1. So ito, magkakaroon dito ng x na variable. So kailangan mo siyang i-add diagonally. So x plus x, that is 2. So yung magiging second term mo dito is 2x. Okay? And finally, this is constant times constant. So walang variable to. Okay? But still, ito yung 1 na coefficient. Ito yung 1 times 1 dito actually. So yung magiging last term niyo is 1. So yung x plus 1 times x plus 1 is x squared plus 2x plus 1. Okay? Pero ginawa ko siya on a table. So, i-apply nyo yan actually dito para ma-eliminate din yung pangailangan nyo to actually write off x's here and their exponents. And you see that you'll have the same results of the signal values for your y of n using this table. Okay? So yan. Yung technique na turo ko sa mga students pagka page 3. Kasi that's the only way na makapag-produce sila ng values kapag kasi kapag yung actual algorithm ng aabutin sila ng siyam-siyam sa pagka-table pa lang. Okay, so that is why. Okay, that is why tinuturo ko yan sa Pero sa inyo, you don't really need to use that as part of your solution sa quiz. Kasi unang-una, pwede niyo naman tong i-MATLAB eh. Okay. May mas madaling solution nito sa MATLAB which naka-indicate din dun sa ibang parts ng mga example ninyo. Okay? Naka-indicate naman siya dun sa ibang parts ng example. Okay. So yan, meron namang ito. May example dito Hindi ko ginawa yung MATLAB solution para sa convolution sum ng example 2 ninyo. Okay? Pero ginawa ko siya sa example 3 para makita niyo yung effect nung nung makita niyo siya sa ano, sa makita niyo yung effect ng mga step by step process nung ano, nung convolution sum and yung substitution actually. Okay? By the way, ang example 3 kasi deals with ano, convolution sum for two infinite duration sequences. So kung ang example 2 dealt with ano, two finite duration sequences. Okay? Example 3 would deal with two infinite duration sequences. So yun yung pag-uusapan natin for example 3, which I would put na lang on a second ano, on a second on another ano, on another part of the on another recorded lecture. Okay? So ayun.
Good morning. Dinig ba ako?
Dinig po, sir.
Okay, so ayun, sabi ni Mr. Lapos nagcha-choppy. Oo, akala ko sa ano ko lang. Akala ko okay naman yung connection, nasa ano ko lang. Sa Bluetooth ko lang nagpuputol-putol, yung pala lahat pala kayo nagcha-choppy na. Okay, so sorry doon. Probably connection ko 'yun sa connection nung ano, nung laptop ko. Anyway, kung meron kayong parts na hindi masyadong naintindihan, again, itong mga pine-present ko sa inyo mga ano, mga lectures and presentations are uploaded sa ano niyo, sa playlist niyo. So pwede niyo siyang tingnan doon para yung mga na-miss niyo na parts dahil nagcha-choppy or something like that. Pwede niyo i-check doon sa ano, sa naka-upload na recorded presentation. Okay? So ayun. Now, so nakita niyo last ano, yung doon sa last part nung ano, nung presentation ko was that I was presenting ano, an equivalent operation, an equivalent and familiar operation na related sa convolution sum. Okay? Na related sa algorithm ng convolution sum. Okay, which is yung multiplication nga ng polynomials. Okay, so ayun nga, as I explained sa presentation, tinuturo ko siya sa mga students ko noon during the face to face during the face to face na classes, mainly because pag tinanong siya sa quiz, okay, pag ang tanong sa quiz tungkol sa convolution sum at nagpapa-compute ng convolution sum sa quiz, syempre hindi niyo naman magagawa yung ano, hindi niyo naman gagawa sa papel yung kung paano ko siya dinemonstrate na gawin using the entire folding, shifting, multiplication, and summation algorithm. Hindi siya magagawa ng gano'n sa isang upuan lang. So medyo mahaba yan. So that is why tinuturo ko siya as parang a shortcut. Okay, sort of a shortcut para sa mga quiz na upuan. Pero sinasabi ko nga, you won't need the use of those shortcuts kung pwede niyo namang computein yung convolution sum, okay? Or yung convolution sum, or pwede niyo i-implement yung convolution sum using yung numerical computation niya, okay? Which is gagamitin niyo nga sa MATLAB. Okay? So, yun. So that is why pag kayo naman yung magku-quiz, okay? Pag during your quiz, I don't really expect na gagawin niyo rin yung example na dinemonstrate ko kung paano ko siya ginawa dun sa example. Okay? I would be expecting more of nagagamitan niyo talaga siya ng MATLAB. Okay? So, ayun. So, in the next presentation na ipapanoorin natin, will sandali lang medyo nagbabagal nga yung computer. Mukhang may nag-update or something. Okay. So ayun. In the next presentation, i-discuss ko yung example 3. Okay, yung example 3 nung nung nasa lecture natin. Okay? And dito sa dun sa example 3, dun kasama yung discussion ng paggamit ng MATLAB in terms of determining the convolution sum of two sequences. Okay? So also take note lang na yung example 2 na pinag-usapan natin. Okay? The example 2 that we have just discussed actually dealt with with two finite duration sequences. Okay? Ibig sabihin yung dalawang sequence na i-convolve niyo are of finite duration. Or ibig sabihin yung length nila is finite. Okay? So ayun. In the case ng example 3, okay? Sa case ng example 3, ang i-convolve nyo naman or yung dalawang sequences na i-convolve nyo ay parehong infinite duration. So ayun, that is why makikita niyo yung difference nung pag-i-implement ng convolution sum if you are computing the convolution sum for two infinite duration sequences at saka for two finite duration sequences. Okay? Pero still, dito sa example na to, pinakita ko pareho kung paano nyo magagamit yung MATLAB in order for you to compute for the convolution sum. Okay? With syempre a special consideration. Okay? With special consideration sa case ng infinite duration signals. Okay? So let's continue on watching the presentation. Okay? And ayun, listen in na lang. Ay, wait lang Hindi ko nasama yung audio, sorry. Okay, so we will continue in the discussion of the convolution sum. May audio na yung video.
Opo, sir, meron po.
Okay, thank you for the feedback. Okay, and at this point, we will work on an example 3. So again, we recall that on example 2, we have implemented the convolution sum, or we have found the convolution sum of two finite duration sequences. Okay. Now, in this example, we will attempt to determine how the convolution sum is determined for two infinite duration sequences. So again, pag sinabi niyo infinite duration sequences, yung or sequence, yung length ng sequence niyo is infinite. Okay? So ayun. Now,
Let us determine the step response, Ym, of a relaxed linear time invariant system with impulse response h of n equals 0.5 raised to n times u of n. Okay? So, ganito, no? Kasi yung problem, yung example 3, this is now the problem is stated now in terms of system analysis. Okay, yung example 2 kasi, binigyan ka lang ng dalawang sequence tapos pinahanap sa yung convolution sum. Okay? Ano lang yun, parang mathematical problem lang yun. Pero this time, itong example 3, the problem in example 3 is on the context na gagamitin natin ngayon yung convolution sum sa system. Okay, sa isang system. So, ganito yung natin, no? Ganito yung situation natin sa example 3. So, again, meron kayong system. Okay? You have a system. Now, that system, first thing, is relaxed. Okay? And is linear and time invariant. Okay? And more importantly, it has an impulse response of this Hn. Okay? So, yung Hn na yun yung nagde-describe dun sa system niyo. So, that is Hn. Okay, so since ang system natin is represented by a block, okay, then we can place yung Hn dun sa loob nung block so that it now denotes na yung Hn niyo actually describes or represents the system. Okay, now this system takes in an input of xn, okay, and produces or generates the output sequence yn. Okay, so ngayon, ang hinahanap sa atin dito is step response. Okay, ang hinahanap sa atin dito ay step response. Okay, ano yung step response? So we define the step response, okay, of a system is the system's output. Okay, the system's output when the input is a unit step sequence. So, step response ang tawag natin sa output sequence. Okay? Step response is the output sequence. Okay? If the input fed to the system through the system fed to the system is step input, okay, or unit step sequence u of n. Okay, so ibig sabihin ang x of n natin pala dito is basically ang x of n natin dito, okay, is basically the step signal. Okay, so it means na ang it means that we have x of n, okay, equals u of n. Okay? And then we have to determine y of n. Okay? Given na ito yung input. Tapos, yung system natin is represented by h of n. Now again, sa ganitong perspective, okay, tatandaan natin lagi that the output sequence, okay, the output sequence of a system of an LTI and relaxed system, okay, dapat relax siya ka LTI. Kailangan parehong satisfied dyan ng system. Okay? For one thing, if the system is not relaxed and it's not LTI, hindi siya ma-represent ng h of n. Okay, so therefore, kailangan relax siya tsaka LTI siya para ma-represent siya ng h of n. So the output sequence here is then computed as the convolution sum of xn and hn. Okay? So, para ma-compute natin yung output sequence, okay, kukunin natin yung convolution sum ng x of n at saka h of n. Okay? So, yan yung context ng natin, nung example 3 natin. Okay? So, ayun. Now, so, ito na nga yun. To find the system step response, we use the convolution sum. Okay? So, before we find the output of the system using the convolution sum, Okay, we take note that the system is relaxed. Okay, which is stated naman in the problem. Okay? So, pag hindi kasi siya relax, may mga kailangan pa tayong gawin para maitama siya. Okay? Or para magamit natin yung HN at saka convolution sum dun sa system natin. Okay, now, since we will be using the convolution sum, okay, we need now the formula. Okay, we need now the formula for your convolution sum. Okay, so which is given in equation 3. Tama yun. Okay, now we take note here that for your problem, okay, or in this example, we have determined that your inputs to this formula would be u of n, okay, step signal, okay, para sa x of n, at saka para sa h of n, this is 0.5 raised to n u of n. Okay, so ito yung mga inputs dun sa formula natin. Ito at saka ito. Okay? So again, every time na magsa-substitute tayo, since ito at saka ito, isa-substitute natin dito. Okay? Pag yung x, isa-substitute natin dito. Yung lahat ng n, gagawin natin k. While para sa h, lahat ng n, gagawin natin n minus k. Okay? So, ito, tsaka to, gagawin natin n minus k. So, ayun. So, now, ganito. Based on this formula, okay, so ang mangyari doon is ganito, no? Pag sinubstitute natin siya, okay, ganito yung itsura niya. This is the summation of u of k, okay, times 0.5 times n minus k times u of n minus k for k equals negative infinity up to positive infinity. So, yan yung magiging itsura ng natin, yung pagka-substitute natin, yan yung magiging itsura ng formula natin. Okay? Pero tatandaan nyo to. Okay, tatandaan nyo to. Merong property ang convolution sum, which we will talk in detail later on. Tawag natin dun is commutative property. Okay? So, ang commutative property, in general, ano yan, pwede mong pagpalitin ng operands ng isang operation mo. So, ang operation is commutative if the result is the same, or the result is the same regardless of the order of the operands. Okay? So, ibig sabihin, kung commutative si convolution, okay, instead of actually doing the kasi ang nangyari dito, kaya ito naging h of n minus k. Ito yung naging fold and shift. Diyan tayo nag-fold and shift. Okay? So, since commutative si convolution sum, yung fold and shift, pwede nating gawin instead kay x. Okay? Pwede natin gawin instead kay x. Tapos, i-retain lang natin yung signal values ni h. Okay? So, ito yun. Okay? Kapag in-apply nyo yung commutative property sa convolution sum, ang i-fold and shift natin, okay? Ang i-fold and shift natin, is yung x instead na yung h. So, pwede yun, okay? Since convolution sum is commutative. Okay, so, ngayon, pag ginawa natin to, okay, pag sinubstitute natin ngayon yung natin dito, yung given natin na x of n, which is u of n, at saka yung h of n natin, which is 0.5 raised to n, u of n natin. Okay, this formula becomes the summation of 0.5 raised to k, u of k, okay, times u of n minus k. Okay, for k equals negative infinity up to positive infinity. Okay. Ngayon, ikumpara niyo yun dun sa nauna natin ginawa. Ito. Let's compare that to this one. Okay. So, makikita nyo na medyo mas, mas simple to. Okay. Kumpara dun sa or compared dun sa naunang ginawa nating substitution. Okay? So, instead of actually using this, we will use this. Or we will proceed with the solution using this from this point. Okay? So, that's the thing about the commutative property of the convolution sum. Pwede niyo tingnan between the operands between xn and hn. Okay? Pwede niyo using with the commutative property of the convolution sum. Okay? You can choose between xn so you can choose between xn and hn. You can choose between which you can choose which between xn and hn to fold and shift. Okay? You can choose between xn and hn to fold and shift. Alin sa hn at saka xn, yung i-fold and shift natin. So usually, ang rule natin dyan is yung i-fold and shift nyo, yung simpler in form. Okay? So kung sino yung mas simple between xn at saka hn, yun yung i-fold and shift natin. So in this case, between xn at saka hn, xn is simpler than hn. So therefore, yun yung i-fold and shift natin. Ito yung this is what we will fold and shift. Okay? Giving us this formula. So yung formula natin na yan, okay? Now, now here's the thing. May makikita tayong dalawang step signal dito. Okay, isang UK, tsaka isang U of n minus k. Okay? Essentially, ang gagawin ng dalawang step signal na yan, or step functions na yan, is papalitan niya itong limits na to. Okay? Dahil yan sa mga definitions niya. Okay, so paano nito papalitan yung mga limits? Okay? So we take note that UK, okay, since ang natin dito, ang limits ng summation natin, okay, is from negative infinity up to positive infinity. Okay? So we'll have UK here from negative infinity up to positive infinity. But take note that the step signal UK is defined as 1 for positive k and 0 for 0 and positive k, and 0 siya for negative k. So which means, okay, this would imply na from negative infinity hanggang negative 1, okay, from negative infinity hanggang negative 1, 0 ito. Okay, 0 tong u of k ninyo. Okay? So kung 0 yan, regardless of the value of the other two factors, okay, regardless of the value nito, tsaka nito, for these values of k, okay, yung product sequence niyo magiging 0. Okay? So for k from negative 1 hanggang from negative infinity hanggang negative 1, okay, the product sequence UK0, U of k equals 0, and it would imply that the product sequence okay, becomes 0 also. Okay? So, ayun. Now, on the other hand, tingnan natin to, no? U of n minus k. Okay. Ngayon, ang U of n minus k, tatandaan niyo isa, no? Lift and shift ito. Okay? Or folded, time folded and shifted ito. Okay? So, which means, kung nagmula yan sa nanggaling muna yan sa U of negative k. Okay? Ngayon, kung yung U of negative k nyo, since flipped yan, ibig sabihin, kung flip version siya nito, ibig sabihin, 1 siya kung 0 and negative yung k nyo. Lahat ng negative, lahat ng mga 1 yung values, nandun sa negative values of k. At 0 siya pag positive yung k. Okay? 0 siya pag positive yung k. Okay? Sorry. 0 to. Yan. Now, ngayon, isi-shift kasi natin to para maging ganito. Para maging U of n minus k. Pag shift natin ngayon yan, regardless of the amount of shift, tandaan nyo na lahat ng mga values sa kaliwa, okay, is 1. Okay? And lahat ng values ng kaliwa nito sa 0, okay, ay 1. At lahat na nasa kanan ng 0 ay 0. Okay? Ito, may example lang ako. Ayan. So, ngayon, pag shift natin siya, okay, pag in-applyan natin siya ng shift, say for example ito, okay, may 6 dito, no? Pag in-applyan natin siya ngayon ng shift na 6, pansinin niyo na ito yung 6 k equals 6. Ayan, ito. Pansinin niyo na simula 6, okay, at pababa. 6, 5, 4, 3, 2, 1, pababa yan. Okay. Ang value niya, 1. Okay. While, pagkatapos ng 6, so simula 7, ito yun, k equals 7, pataas, 0 na siya. Okay? So, ganun din yan kapag halimbawa, ginawa natin U of, say for example, negative 5 minus k. Okay? Ang magiging value niyan is 1 siya for k less than or equal to negative 5. Okay? Ibig sabihin, bago dumating yung negative 5, hanggang sa negative 5, or k equals negative 5, ang value ng U of k nyo is 1. At 0 siya for k greater than 5. So, ibig sabihin, pag lumpas siya ng 5, nag-6 na yung k nyo, magiging 0 na siya. Okay? So, in general, okay, yun na nga, no? Yung value ng U of n minus k ninyo is 1 for k less than or equal to n. Okay? So, sa kaliwa ng n, 0 siya. 1 siya. Okay? Sa kanan ng n, 0 siya. Okay? So ngayon, ano ngayon ang gagawin doon sa signal natin? Okay? So ano yung gagawin niya doon sa natin? Dito. Okay? It means na pag ang value ng k nyo, okay? Pag ang value ng k nyo, okay, is from negative infinity, okay? From negative infinity hanggang n. Okay? Pag ang value ng niyo, binulo kayo. Kapag ang value ng k nyo is negative infinity hanggang n, okay? Ang magiging value ng signal nyo is 1. Okay? And then, from n, okay, or from n plus 1, ibig sabihin, lagpas ng n, okay, hanggang positive infinity, okay, ang value ng signal niyo ng U of n minus k ninyo, equal 0. Okay? So, simula n plus 1, okay, simula n plus 1 hanggang positive infinity, okay, ito, magiging 0 din. Now, at these values of k, regardless kung ano yung value ng mga to, okay, regardless kung ano value ng 0.5 raised to k at saka ng U of k, sa mga values ng k na to, basta ito yung values ng k, mag-0 tong factor na to. Okay? This would still lead to a product sequence of 0. This would lead to a product sequence of 0 equal to 0. So, ibig sabihin, Okay? Ibig sabihin, from negative infinity hanggang negative 1, 0 yung product sequence niyo. Okay? And from n plus 1 hanggang positive infinity, 0 din yung product sequence niyo. So, ano nga yung mangyayari dun sa natin? Ano yung mangyayari dun sa signal natin or saan natin, sa summation natin? So, since from negative infinity hanggang negative 1, 0 siya. Okay? At from n plus 1 up to positive infinity, 0 din tong product sequence niyo. It would now be obvious na itong itong limits natin ito, okay, magkakaroon na siya ng value pala. Okay, hindi magiging 0 yung niya, yung product sequence niya. Okay? Kapag yung k niyo equals 0, okay, simula 0 hanggang n. Okay? So, kasi from if your k is from 0 up to n, okay, yung u of k niyo is equal to 1. Kasi positive yung okay, positive yung k. Okay? While yung u of n minus k niyo, okay, is also 1. Kasi this is 1 when k is less than n. So magiging 1 din to. So ibig sabihin, yung limits ng summation natin, papalitan natin ng 0 to n. Okay? And at those values of k, ito magiging 1, ito magiging 1 din. Okay? So ngayon, pwede natin i-rewrite ngayon yung formula ninyo. Okay? So kung mare-rewrite natin yung formula ninyo, okay, magiging ganito siya. Okay, itong formula natin na to, okay, can be now rewritten, okay, as y of n. This now can be written as y of n equals the summation of 0.5 raised to k, okay, for k equals 0 up to n. Tapos yung dalawang factors na to, since from 0 to n, 1 nga yan pareho. So, times 1 na lang yun. So, ito na yung may iwan. Okay, so this now is to be written here, applying the definitions of your step signals. Okay, so, continue with this. Okay, this is now a geometric series. Okay, alam na natin na this one is a geometric series. Okay, in this case, this is a finite geometric series. Okay, finite geometric series siya. Okay, so meron lang siyang length na, or meron siyang haba na n plus 1. Okay, so the sum, okay, of a finite geometric series, okay, again, is provided to us dun sa formula 8 ng lesson 2.1. Okay, so ito na yung nilagay ko na dito. Okay, pero again, kung maghahanap kayo ng mga formulas for sums of geometric sequences, or series to but sequence series yan. Okay, if you would be looking for sums or formulas for sums of geometric series, okay, nandun siya sa formula, nasa lesson 2.1 siya, nasa formula 8. Okay, so ito yung sum ng finite geometric series natin. Okay, given na yung base nung niyo, o yung a niyo is not equal to 1, tsaka kung equal to 1 siya. So in this case, ang a natin kasi dito is 0.5. So therefore, dito tayo maghanap sa not equal to 1. Okay, so now, in this case, makikita rin natin na yung upper limit natin dito is yung small n natin. So we have now the following parameters of our finite geometric series. Okay, so i-apply natin ngayon yung formula na to. This becomes y of n equals 1 plus a raised to n plus 1 over 1 minus 2. So magiging 1 minus 0.5 raised to n plus 1 over 0.5. Or pag sinimplify natin to, okay, magiging yan? 1 minus 0.5 raised to n plus 1 over, magiging 0.5 kasi yung ilalim. And 0.5, 1 over 0.5 natin is actually 2. Okay, so that becomes this one. Okay, so now your output sequence now, your output sequence now is 2 times 1 minus 0.5 raised to n for n greater than or equal to 0. Okay, so obviously, i-define natin yung output sequence nyo for n greater than or equal to 0 since the convolution sum generates the output of a relaxed system. Okay? At pag ang system nyo kasi is relaxed, okay? Pag ang system nyo ay relaxed, we tend to think na yung indices nyo na negative would cause or would have your output sequence to be 0. Okay? So pag negative yung indices nyo pag negative yung indices nyo on a relaxed system, yung output sequence nyo is 0 kasi nga ito yung ang negative indices kasi or ang values ng nung output sequence niyo, okay? The values of the output sequence when the indices are negative or when the indices are negative is considered to be the state of the system. Okay? So yun yung parang pinaglalagay ng state ng system. Okay? And in this case, since relax nga yung system natin, we will now observe na dapat yung state of the system natin should be 0. Okay? Wala dapat naka-store na values dyan. So therefore, itong output sequence na to applies at this interval. Okay? So ngayon, pansinin natin ngayon na yung convolution sum ng infinite duration sequences. Okay? The convolution sum of infinite duration sequences is an explicit expression for yn in terms of n. So, ito yung sinasabi ko before, okay, na ang objective natin dito, okay, in the analysis of system, one of our objectives in the analysis of systems is to determine y of n or determine the output sequence, okay, as a function of n. Okay? So which means itong right side natin should just simply be an expression, okay, containing n only as a variable. Okay? So ito na nga yun. Yung hinahanap natin. Okay? So, ngayon nga gagawin natin, no? Kasi what we would like is to verify the, what we would like is to verify the, this one, yung results na nakuha natin. Okay? So, at this point, we will be using yung numerical computation ng convolution sum. Okay? In which we will be modifying yung built-in function ng MATLAB na CONV. Okay? So, merong function si MATLAB na CONV. Okay, i-modify natin siya and write the FCONV na function. Okay, so this is now a custom or a user-defined function. Okay, which is a modification of built-in CONV function of MATLAB. Okay. Function of MATLAB. So essentially, ang CONV function, it actually computes the convolution sum of two sequences. Okay. Medyo i-modify lang natin siya. Okay. Para ma-modify din natin yung para kasabay na mailagay din natin yung indices. Okay. Nung output sequence natin, nung input sequences natin, tsaka nung output sequences natin. Okay. Kasi si MATLAB kasi, yung CONV function niya, it just computes the convolution sum of two sequences. Okay, it computes the convolution sum of two sequences regardless of the time indices. Okay, of actually basta sa kanya ang indices ng bawat sequences is 1 to kung ilan yung haba ng sequence niyo.
Good morning, class. Ganito, no? Kasi medyo alanganin pagka tinuloy natin kasi 4 minutes na lang yung meeting natin. So I'll stop the presentation right there. And the member na ang i-discuss na supposedly in your presentation is yung the manner by which kasi ang gagawin ko sa presentation na kasunod nito is first babalikan ko yung example 2. Okay, babalikan ko yung example 2 at ipapakita ko kung paano or ipe-present ko kung paano magagamit yung MATLAB function na conv at saka yung user-defined function na fconv para makuha natin yung sagot sa example 2 or para ma-verify natin yung sagot sa example 2. Okay? So that's one. Second is gagamitin ko yung fconv function para ma-verify ko tong sagot na to. Itong sagot na y of n equals 2 times 1 minus 0.5 raised to n plus 1. Okay, paano ko siya i-verify? Ang gagawin ko is since given ako ng dalawang signal na xn at saka hn, bali magge-generate ako ng values para sa xn o sample values para sa xn at saka sample values para sa hn for a certain range of or for a certain time interval. Ang gagamitin ko dyan is -5 to 20. Okay? Tapos, so yun Tapos yung sequences na ma-generate ko doon is i-convolve ko. Okay? I-convolve ko siya using fconv. Okay? Then, so yun. So yung sequence na ma-generate ko using fconv, okay? Is titingnan ko, okay, kung pareho ng values ng sequence na ma-generate pag ginamit ko tong formula na to at yung n, pinalitan ko from -5 to 20. Okay? So, kung pareho kasi yung signal values na ma-generate ko on both process, that is number 1, yung numerical convolution sum, and yung second is yung implementation ng explicit formula na to. Kung pareho yung sequences na ma-generate ko on both cases, then masasabi ko na yung dalawang proseso na ginawa ko are equivalent processes. And therefore, masasabi ko na equal or tama tong formula ko na nakuha ko using analytic solution ng convolution sum ko. Okay? So, ganun yung magiging approach nung mga susunod na i-discuss niya. Now, I'd ask you to i-upload ko to dun sa actually hindi ko pa siya na-upload ngayon. Pero i-upload ko siya dun sa sa playlist niyo. Doon niyo na lang panoorin yung kasunod. Okay? Then para sa susunod na sa susunod na meeting o sa susunod na presentation, yung topic after na ng example 3 yung ipe-present natin. Okay? So, I hope those things are understood. Okay? So, again magkakaroon ako ng announcement sa na may kinalaman sa quiz number number 2 ninyo. Okay? Tapos mamaya, yung sa mga estudyante ko sa laboratory later, okay, magkakaroon tayo ng live session mamaya. Although iniisip ko kasi kasi ready na yung ready na for deployment yung for assignment yung yung activity 2 ninyo. Okay, may mga inaayos na lang ako ng konti dun sa ilang mga questions. Okay. So, mamaya ready na 'to. Okay. So, I think I can meet you for discussion ng activity 2. Okay? Although tingnan ko kung madi-discuss ko ulit yung activity 1 kasi hindi ko maalala kung yung huli natin na pag-usapan last time . So, ayun. So sa mga estudyante ko sa sa lab mamaya, I'll see you later. Okay? Mga ano tayo, I'll start the meeting by by 11. Pero sige, mamaya natin pag-usapan kung anong oras tayo magsisimula ng live discussion. Pero basta by 11 magsisimula tayo ng ng discussion. Ay ng meeting pala. Okay? So sige, let's dismiss the class and I'll see you on